Hello, class. For today, we're going to do a summary quiz review. I know it says then marking period quiz one on top of it, but please just don't mind that. We are going to take a look at um, the several questions that we have been dealing with over the past couple of weeks, and not the past couple of weeks, past couple of days. We have triangle inequality on the first page. All of these questions are talking about the triangle inequalities, and you guys can take a look at the notes for that one. And then the second one is the most recent one that we have talked about, the not inscribed angles, the angles of the polygons and those kind of things. And this third one here, this might be a little bit tricky, so I'm going to help you out with that. And remember, this is a quiz review, not the actual quiz. So what I would like you to do is I would like you to, try these questions on your own first, and then I'm not going to go over every single detail of this question, but I will make sure that I upload the answer key for you as well to see. And the last part is the Cavalier's principle and that kind of thing. So these three topics is meshed into one. So there's a lot of things that you need to be taken to the accountability for. But the quiz itself will be very very short, and that will be holding place for tomorrow. I'm gonna just upload the quiz for you guys to have, and this will go into your marking period as a test grade instead of a quiz grade, because we all know how our quiz grades is pretty strong, but we're lacking some test grades in there because we have only benchmark and those kind of things. So that would be for this tomorrow would be for the test grades. So let's get started right away. And for the triangle inequality questions, I'm sure that you guys will not have too much problem with this, but given the length of the two sides of a triangle, determine the range x of possible side lengths of the third side with inequalities. So with these questions for tomorrow, what you want to do is, I hope you remember that it's x and then it's b plus a and b minus a. B being the larger number and a being the smaller number. So the triangle inequality always states that the third side has to be less. So third side has to be less than this first and second um, sides combined. When we say the third side, we really mean the largest. So here, if I get 5 and 11, I'm going to give an inequality format like this. X is between these two. And I'm just going to fill out the blanks here. So X is between 16 and 6 because you just have to add them and you have to subtract them. And if X is anything beyond that, it's going to be not a triangle. So for example, if the last side was, let's say for example, 16 kilometers, 5 plus 11 is 16. And remember, we always said that the first two sides, the lower two sides, has to add together to become larger than the last side, which makes no sense. So therefore, it has to be less than 16. Something like 15, 14, 13 would do, but not anything other than those guys. This one here would be 35, and this would be 15 yards, to be more specific. That would be it. A student draws a triangle with a perimeter of 36 centimeters. The student said the longest side measures 18 centimeters. How do you know that the student is incorrect? Well, if you take a look, the largest side is 18. That means I have two more sides to go on about it on a triangle, but the entire perimeter of this is 36 centimeters. So what that tells us is that these two added has to give you something that is going to be bigger than 18. But if you subtract 18 from 36, these two added together, believe it or not, just turns out to be 18. So what we say is, we know the student is incorrect because, I'm just going to say BC for because, the lower two sides added is not greater than the lower two sides added together is not greater than the largest side. That will be my way of putting it. You don't have to copy this word for word, as long as you can show me the understanding that these two, this plus this added together, like this plus this, does not give you something that is greater than 18. Then you should be fine along those lines. Next, a kitchenware triangle is made up of the stove, sink, and the refrigerator. So we have those three. What are the possible distances between the sink and the refrigerator? We're talking about these two lengths right here. Okay, so how do we figure that? Well, it turns out that these two are the lengths. So between sink and the refrigerator, we need anything that's greater than well, it's pretty much the same similar situation as these guys that we have done in the past. We just simply say, okay, it's this minus this, so it's 0, and this plus this, which gives you 112 inches. So that those are the possible distances. Because if this was 0, first of all, that really can't happen and make a triangle. But if you make this into a 1 or 2 or 3 all the way down to 111, it makes sense because as long as any combination of two sides added gives you larger side than the last one, then you should be fine. For maximum efficiency, the distance between any two of these locations should be between 4 feet and 9 feet. Notice that this is 4 feet and 9 feet and not inches, so we want to convert them into inches first. And you get 48, and this is 108. Is it possible for this kitchen work triangle to satisfy those requirements? Okay, well, we want to make sure the distance between any of these two locations. Well, we have 56, and we have 56. And then the last one here, it could be anywhere between 0x and 112. So is it possible for this kitchen to work? The key word here is possible. So that means that we want to give some room of doubt and say that it's not a must-be situation, it's a possibility. Triangle to satisfy this requirement, and then the answer to this question, believe it or not, it should be yes. Why? Well, because the 56, first of all, these two, is between that required, required a set of a, what you call it, the boundary, and this here, the last side, well, we can have something that's between 48 and 108 because that is within this boundary here. So, I mean, you can just call it anything. Call it 50 if you want to, or call it 56. So make an equilateral triangle, it doesn't matter. But because all three sides falls into that boundary, 48 between 48 and 108, then yes, absolutely, it's satisfied that all those three sides will be within this boundary given right here. Okay, and it's a possibility, it's not a must-be situation. Next, fill in the table below. Now this is what we have learned yesterday, so it might be still a bit of a iffy, but just pause the video for now and then just really try this on your own before you actually attempt this and get the answers here. So fill in the table below: number of sides, sum of the interior angles, angles of one interior angles, and angles of one exterior angle. So we have done this before in the past. I mean yesterday. So let's just review. First of all, the formula, you got to write down the formula here. It's 180 times n minus 2. This is for the summation. Oh, I should probably write that here. Ooh, I'm going to erase all this. So this is n minus 2 times 180. This right here is the answer that I have found out from the previous column. So I have to do 180 times n minus 2, whatever that was, and divide by n, the number of sides. Angle measures of one exterior angle. Well, exterior and interior angles, remember, they turned out to be supplementary, which means, well, I can't write there, supplementary, which means this right here, whatever the answer that we have found here, you just have to do 180 minus the interior angle that we have found out from the previous column. So for example, let's say that the number of sides is 12. I plug it into this formula here and I get 1800 degrees for my total sum of interior angles. Next, I use this information to find out the angle measures of one interior angle, which is 1800 divided by 12, which should give you, let's use a calculator here. 1800 divided by 12, which gives me 150 degrees. And that's how I know the measure of one interior angle. And from here, it's like a domino effect basically, right? So after I find out the 150 degrees, then the exterior angle should be 30 degrees because these two added together should give you 180 degrees and so forth. Now, if you were to go backwards and say, I have one exterior angle, then you just have to simply go back. You have to do 180 minus that. So what you're going to get is 165.6 degrees as your measure of one interior angle. Now, how do we go from here to here? Well, you just have to simply take the number of sides n, and then you have to multiply to here to get the sum of the interior angles. But really, most importantly, is that we want to figure out the number of sides first. So plug it into this formula here, or plug it into this formula there. So what I mean by that is the work for this, I'm going to write it here. 180 n minus 2, the sum of the interior angles, divided by n, should give you 165.6 n. I'm sorry, 165.6. And this is a simple equation that you just want to solve for. So here, what we're going to do is we're going to multiply both sides by n. So we're going to do a little bit of an algebra. 180 times n minus 2 is equal to 165.6 times n. Distribute the 180 on both. Okay, and then you're going to move the variables around. So what I mean by that is to subtract this to the left-hand side and add this to the right-hand side. And what you're going to get is I'm going to get 14.4n is equal to 360. Okay, because this turns out to be positive once you add. And once you subtract 180 minus 165.6, you get a 14.4, but don't forget your variable n. Your final step is to divide both sides by 14.4 and just get really what n is going to equal. So 360 divided by 14.4 gives you exactly 25. So that I know that this right here, n is equal to 25, and when I plug this back in here, you get 23 times 180 and get the total of 4,140 degrees for your summation, sum of the interior angles. So no matter what, you're going to just simply take the information that's given to you guys and then just plug it into the respective formula and then just get the answer from that already. This column, this last row right here is going to be the same as the first row, just so you just have to apply it. I'm going to leave these two rows blank for you guys to do. Like I said, I'm not going to go over every single detail about these questions. Why is the sum of the angle of polygon always a multiple of 180? You have to use this for the most part. And because every single time, or remember yesterday, if you take a look at the video, I gave you guys an example of how every single time I add up from triangle, square, pentagon, and hexagon, that when n is 3, 4, 5, and 6, it just keeps on getting multiplied by 180, 360, 540, 720, keeps on getting added by 180, and that's the pattern I wanted you to recognize. So along those lines, if you could just describe them for me, that would be perfect. And this one here, I'm going to leave this blank so that you guys can try this on your own. Remember that I'm going to solve this for you guys on a separate file so you guys can have the answer key. But for now, I want you guys to try number 6 on your own and make sure that you guys are studying for this. Okay. Number 7. Number 7 is a little bit of a little tricky, and a lot of students had questions on this. But here's what's going to happen. This is something that we really haven't learned, like in the past, like all together. It's not something about interior, not the interior angles of a polygon. Well, it's kind of technically is, but most likely what you're going to be doing is using supplementary angle. And using what we know about the summation of triangles being 180 degrees. These are really the main two things that you have to know to do this problem here. So the very first thing you need to recognize is, okay, first I have a lot of these variables that I need to be looking for. Which one do I go first? Well, the easiest one that you want to go for is B. Because there's no specific order in which how you're supposed to be solving this, and you can just do it however you like. B is simply 180 minus 133. Why? Because these two create what we call a supplementary angle. So B plus 133 should give you 180. Subtract 133 on both sides, and then you get B is equal to exactly what this says. So your final answer should say 47 degrees for B. Okay, that was simple. Okay, so how do I? Oh, I'm sorry. The last one should be vertical angles. And I'm sure that should ring a bell when I say vertical angles. Vertical angle is simply the angle that is facing towards each other. So when these angles are facing towards each other, I know for a fact that this also is 47. So it's sort of like Sudoku in a way, where you're constantly, once you have the angle for the first part, then you have the angle for the second part, and you keep on going on and on and on about that. That's great and all, but then that really doesn't tell you what E is. So now you got to look at somewhere else to find the clue. There's another supplementary angle there for you. Okay, so that's 140, and I know this is not indicated by any other variable, but we know for a fact that that's 40 degrees because 140 plus 40 gives me 180. Now using this right here, okay, using this information and this information, you can actually use that to solve for D. So 40 plus 47 plus D should give you 180, using that information about some of the interior angles being of a triangle being 180. So 87 plus D equals 180. So D is going to simply be 93 degrees. Okay, so I'm going to go to my D and say that that's 93 degrees right there. Okay, if I ask you to show your work, this will be the showing the work for D part. Okay, so that was good. Okay, so now what can I do? I can use this answer for letter D here and say that's 93. Okay, that's 93 because that's vertical angle. This one right here, that's 40 plus 93 plus this question mark should give you 180 degrees. So that's 133 plus question mark gives you 180 degrees. So that should give you 47 degrees right there when you solve for it. I know I'm going a little too fast about this, but you just have to bear with me. Once you do your math, you should get the answer like that. That's 47 degrees under the vertical angles, and the whole reason why I went from all the way from here to here is because now I can use that information to solve for E now. So E, if you take a look, it's an isosceles triangle where this angle is 47, that angle is 47, so E plus 47 plus another 47 should give you 180 degrees once again. So once you add those two together, you get a 94, subtract 94 onto the other side, and you get 86 degrees for E. So I'm going to go to E right here, and I'm going to write 86 degrees. Okay? So I have now two letters left, A and C, and now what I have to do is I have to kind of go this way, right? Now, starting with this 40, now I know that's 40 degrees. Now using this triangle, I can figure out what this is going to be. And using that, I can figure out what this vertical angle is going to be right there. Now, another thing that we might also want to be using is how we can figure out C, because there's really no information, there's a lot of lack of information on this side. So if you take a look at this, the sign in the shape in the middle, we see that it's a hexagon. And if you remember a hexagon, interior angles, they all have to add to give you 720, right? Well, it turns out, I'm going to label this in green, we have 133, we have this angle, we have this angle, we have 140, and we have also this angle. Can you figure out all of these green angles? Yes, you can, because it's supplementary to 47. For example, this angle right here, it should turn out to be 133 degrees as well, because 47, the thing that we just found out for this blue part, okay, right here, should be supplementary to 133, which is right there. So by doing the supplementary angles all around this, okay, and then subtracting away all the green portion, so 720 is the total summation of all of these things combined, minus the 133, minus 133, minus this, minus 144. You just keep on subtracting them. Like, those are not zeros, those are your blobs here and here. And then that should give you your remaining angle, which should be the value for C. And with that, you can find the supplementary angle with B, find out A because it's 180 degrees when you add all these three things combined. Again, I'm going to leave that for you guys to do, but this is the step-by-step basis as to how to solve this question. I know it's a lot for this question, but it's like solving for Sudoku basically in a way. Next, Cavalier's principle. This one, I'm actually going to leave you guys to do it by yourself. Cavalier's principle, I already told you in the previous video what two things it's required for Cavalier's principle, the volume to be preserved. Somewhere along the lines of, perpendicular height should ring a bell. This is the exact same question we have done in the previous video. The coin question in the below picture, which of the following statements will be true regarding the stack of coins? So look at these coins and what is preserved? That is the question. Looking at this photo, you're going to select the two choices that will be the answer choice to this question. The volume of both stacks will be the same. Will they? Then click it. Not click it. Just check. Give a little check here. The area of the cross-section that are parallel to the bases will not be equal to the distorted nature of the second stack. Is that true or false? The height of the distorted track will be distorted stack will be slightly larger than that of the straight stack. Cavalier's principle can be used in this situation to verify that the volumes of the stacks are equal. I believe the two answer choices should be very, very obvious. Using what you know about Cavalier's principle, do these two cones have share the same volume? This, like I said, is the exact same question. So please take a look at these questions. And Cavalier's principle is really, really simple. Take a look at the video and make sure you answer this. And this is a review. And tomorrow I'm going to give you a very simple format version of the test, and that will go in a test grade. Remember that you guys, the market period grades are over in about a week, so I want to make sure all the grades are put in. Some of you guys are sending me a lot of emails regarding your grades, and I get that. I need to make sure that all the grades are put in, make sure you do your retakes, and if you have any questions about your grades, now is the time. Do not hold on to it. And I know that I've been a little bit slower than usual responding to your emails, particularly because I don't see you guys at school. So a lot of these students, what they do is they send me a whole bunch of emails. So I will make sure I get to that ASAP. Okay, make sure you study. Post the answers for you guys after you guys finish this, and you guys have to make sure you guys work on this and show me that you guys have done this. Please submit it to Google Classroom as your classwork. Okay, all right. Have a good day.